This video is part of a series that gives a general overview of the various medical imaging techniques that exist. It's intended for someone maybe studying in a healthcare field who needs just a basic understanding of the types of medical imaging that are out there, their common uses, and the differences between them. So in this video, I'm going to go over what X-ray imaging is, how it works, the history of it, and common applications of it. When I hear the word X-ray, I tend to think of this illuminated skeleton on a black film. So this is an X-ray image, also known as a radiographic image. But what even are X-rays? And how do we use them to create pictures like this? We'll start off with the name. X-ray is short for radiation. Well, the ray part is short for radiation. The X got there because the scientists who discovered this type of radiation didn't know what it was initially. And X, as you may recall from algebra lessons, can be used to symbolize something that's unknown. So he chose X to refer to this type of radiation as he studied it. The name stuck. He apparently didn't intend for it to be named that, but that's what we call them today in most countries. So you'll read in your textbooks and hear in lectures that X-rays are electromagnetic waves of a very short wavelength. Now, what does that even mean? Unless you're studying physics, you don't really need to know. For the purposes of this video, you just really need to know that electromagnetic waves are a form of radiation. So there's different types of radiation, and electromagnetic waves are just one. And from here, I think it would be a good idea to look up a general definition of what radiation is, so all radiation. And I went to Wikipedia and did just that. Wikipedia defines radiation as the transmission of energy in the form of waves and particles through space or through a material medium. Now, when an X-ray image is taken, the first material that the X radiation is going to encounter is the patient's body. After it goes through the patient's body, it travels and encounters the radiographic film behind the body. The X radiation changes the film in such a way that an image of bones and any other dense objects in the body is created. This is able to happen because the dense objects in the body absorb or block X-rays from making it to the film. So where you're seeing bones on this X-ray image is where little to no X-rays touch the film. You can kind of think of X-rays as like those ancient cave paintings where people put their hand against a cave wall and blew pigment towards it, creating this image of their hands. The pigment is like the X radiation that makes it to the film, and the hands are where those X-rays were blocked from reaching the film. Now I'd like to talk about a bit about the history of how X-rays were discovered, because it's a good byway into explaining how X-rays are generated and what they're used for in medicine. So in 1985, a physicist named Wilhem Röntgen discovered this type of radiation. As I said before, he didn't know what it was, so he just started calling it X radiation, X meaning unknown. And Röntgen didn't just discover X radiation He also made the first X-ray image of a human body structure, and he did that in his own home, in his study. Back in 1985, it was common for scientists such as Röntgen to have photography supplies lying around their labs because they sometimes wanted to document their experiments and findings. So film wasn't around yet, so what was used to make photographs in 1985 were these thin glass plates that were coated in silver salts. And this is what was used to make photography negatives before film was created. Now, if you only know what digital photography is, you've never looked at photography negatives, go research that. You'd probably have to be really young to not know what photography negatives are, but I think there might be now a lot of people who don't. So anyways, Röntgen happened to have these glass plates lying around, and 6 weeks after he discovered X-rays, Röntgen made an X-ray image of his wife's hand. And here it is. So much like today, the X-rays were directed towards his wife's hand, while an imaging material, in this case the glass photography plate I showed you, was behind her hand. So her bones are denser than the other material in her body, so more X-rays were absorbed by them. So they don't make it to the film, and hence you have this likeness here of what the bones in her hand looked like, as well as her wedding ring on the ring finger. Röntgen later created a higher quality image and presented his discovery to other scientists at a conference. Something you might be asking yourself about this image is why are the bones dark and the surrounding areas light? Because in X-ray images you're used to seeing, the opposite is true. The bones are light and the rest of the image is dark. The reason why this is because Röntgen developed this image from the negative he initially created. Essentially, he did what many of us would have done because it would have seemed natural. He made a photograph out of the negative. Today, X-ray negatives are not usually developed into photographs, and what you see are the negatives, such as this one. So, in case you're wondering, this is what X-ray film looks like before it's been touched by X radiation. So much like the photography plates that Röntgen used in 1985, this film is coated in silver salts. And why this is because when the X radiation comes into contact with the silver salts, it converts the substance to metallic silver. So when it touches the silver salts, a chemical reaction occurs and it becomes metallic silver. Metallic silver is opaque enough that light doesn't come through when the X-ray image is placed over a light box. You've probably seen that on like television shows where they take the X-ray film and they place it over the light box. So now we've talked about what happens when X-rays move through the body and how dense objects absorb the rays. And we've talked about how what happens when the X-rays reach the film. But how are X-rays created? I'm going to give a really basic explanation of how X-rays are generated. To generate X-rays, you need what's called a vacuum tube. And a vacuum tube is essentially a glass tube that's had all gases, so mainly oxygen and nitrogen, removed from it. And inside this vacuum tube, a beam of electrons is directed at a piece of metal, and it's usually copper, I think I read. And when the beam of electrons reaches the copper, it destabilizes the metal atoms, and as these metal atoms try to get back to a stable form, X radiation is emitted. Anyone watching this probably isn't too surprised that X radiation has something to do with atoms being unstable. Most of us have heard that atomic bombs or nuclear weapons, they involve an atom being split, and therefore the atom is made to be very unstable to the extent that this huge amount of radiation is emitted. You've also probably heard that heavier atoms in the periodic table of elements, such as radon or uranium, which I've circled here, they tend to have an unstable nucleus. And as a result of this nuclear instability, they put off radiation. So with X-rays, we have the same thing going on. An atom is made to be unstable and it emits radiation as a result. So I've gone over how X-ray images are made and how X radiation is generated. Now I'm going to talk about how X-rays are used in clinical settings. So X-rays aren't good at creating images of soft tissue, such as tendons or ligaments, because they don't absorb the X-rays. So they're generally not used to, X-rays are generally not used to detect sprains, which is damage to a ligament, or something like muscular injury. They do create good images of bones, or any other dense object in the body. So they're used to detect osteoporosis, fractures, or foreign objects lodged in the body. The picture shown here depicts a shotgun wound. So here's an X-ray machine over this table that the patient would lie on. And the film would be somewhere, it would be slipped under the table somewhere here. Now, this is an X-ray machine that would take X-ray images of your teeth at the dentist. And when I was researching X radiation and how X-ray images are taken, that got me thinking about, hey, when I'm at the dentist, where's the film? I mean, I don't see any film behind my head or on the other side of my head when they take the images. And I did some research, and I found out that this is the film. That thing they get you to bite down on at the dentist, well, it's called a bite wing. And the part of it that's between your tongue and the side of your teeth, that is the film. I didn't know, and I found that the coolest part of this project was finding that out. And so far, everyone I've talked to and I've asked, do you know what that thing is that the dentist gets you to bite on before they take the X-ray? No one's known yet, so if you didn't know, have fun with that, telling everyone. So beyond creating images of bones and foreign objects in the body, X-rays have a few other uses. They're also used to detect abnormally dense tissue. So they're used by mammography machines, and they're also used to detect tuberculosis nodules or tubercles, as depicted here. Another common use is to detect tumors and ulcers in the GI tract. So for organs like this to be visible on an X-ray image, the patient needs to ingest or be injected with a contrast medium containing heavy atoms, such as barium. So that is it for X-ray imaging. In my next video, I'm going to give a basic overview of computed tomography. And that is a medical imaging technique that also uses X radiation, but it uses it in a more technologically advanced way.